you all get a notification? Are those like this meeting is being recorded notifications? Are they gone now somehow?
It's saying recording in
It's
the
saying
top
recording.
left, but it didn't
Yeah,
give the verbal like it used to.
yeah, that's weird. Maybe they stopped doing that. Anyway, this is all then being recorded, right? All right, so today we're going to talk about, we're going to do a little bit of an introduction to the internet, just kind of a light start on a Monday morning. I'm sure you've all gotten the chance to take a look at some of the labs over the weekend. We're actually not going to dive too much into Rails today. We're going to start with an introduction to Rails tomorrow, so that it's a little bit, I feel like it's a little bit more of a relaxed start to the week. So starting with the introduction to the internet, I just want to give you a little bit of an overview of, kind of where the internet came from, how the web works, and then some information about this like thing that we call the request response cycle. Essentially, like how do computers talk to each other over the internet? So we'll go through all of that. The README is pretty extensive here. I'm not going to go through each and every, read each and every sentence. Feel free to kind of jump back to that if you want to read a little bit more. I'm mostly gonna like be hanging on these images that I added to this README. So first of all, the internet, like history of the internet. How did the internet get started? So the internet like really kind of came to be what it developed into now in the 1960s, when computer scientists developed something called packet switching. Packet switching is a way to send data across a network by breaking it into like little chunks, so that it's easier to send that data from computer to computer. And one of the first working prototypes that was that you could consider like an internet was called the ARPANET, and it was actually one of the first ones that where we tried to communicate some piece of data from one machine to another machine, across huge distances. And fun fact, the first message that was supposed to be sent over the ARPANET was supposed to be the word login, but they were only able to send 2 letters, the L and O, because after that the machine crashed. Nowadays we can do a lot crazier things. We can send more than just a couple of letters over the internet, but that was how everything kind of started. And the internet itself is pretty much like what it is like a network of cables. As you can see here, this image, I think that's kind of cool. These are the cables that connect us all, right? This is how the internet works. So we have these fiber optic cables, usually underwater, going through the oceans, and they're there to connect our different machines to each other. And then here I have a little fun fact. I got this little shark in here. So apparently, I didn't actually realize this. One of the biggest, or probably one of the biggest problems about these cables in the ocean is that sharks bite them. I don't know if anybody else knew that, but I found out that that's apparently a problem. Does anybody have any questions about like how the internet got started? These cables in the ocean, the sharks. I don't know if I know more about that, but
With the cables, I've always seen representations like this where the cables are going across the oceans and then magically the landforms are all blank. Is there any reason that the internet is not represented on land? Is that just because it splits into so many other segments and types of cables, providers, etc.?
yeah, I think so the cables still go on land. I think like once you draw the cables on land, it will be hard to see like where all the countries are because it's so many. So I think usually, like if you see these kinds of representations, it's just the cables that are in the ocean. But I wonder if there's like, let's see, internet cables. Let's see if there's another representation of it. Yeah, you usually just find these. I'm not exactly sure why either. I guess like that's the interesting part. Maybe the others are hard to draw out because they're so like scattered.
Yeah, I think that would make sense. I'll do some digging on that too. I'm just kind of curious.
Yeah, let us know if you find something interesting. Cool. Any other questions?
Yeah. Is this all on our class repo? The same one?
This README right here?
Yeah, or the lecture notes and everything like that.
Yeah, I'll upload all of this for you.
Okay,
so
cool.
You can take a look at it afterward for sure. Cool. All right, and then so the thing that we pretty much use all day is I mean, we use the internet, but more specifically the web, right? So the web is actually something that is like kind of built on top of the internet, and it is there for us to be able to like consume and distribute information on the internet. The web was created by Tim Berners-Lee in 1989, and is pretty much what we use nowadays for getting through web pages, you know, finding links on the web, clicking on them, like kind of navigating all over the place. And we'll explore a little bit more about like how, you know, how do we actually navigate to different pages? Like, what does that look like? What's the protocol that we use? So this is the protocol that we use over on the web to like navigate to different pages. If we go to google.com or wherever, it's called the HTTP protocol, or HTTPS. And we'll kind of explore like what the different parts to that are. So like, you know, essentially like how the web works. I added a couple of illustrations here that I drew. Know that they're not that they're not great, but I think I hope they get the point across. So if we do something like, if we go to a website, right? We go to like flatironschool.com, flatironschool.com. Maybe we want to find like a particular resource, or we just want to go to the homepage. Let's go ahead and do that. We type that into our URL bar, right? So in our case, we don't even have to type the HTTPS part. We can just say flatironschool.com, and it will bring us to where we want to be. So there are a lot of things like going on in the background. We're not going to go into this into too much detail, but I want to dissect a little bit the different pieces that we have that we need in order to make a request like this, to get a page like this back in our browser. So the first part to a URL that we type into the URL bar is the protocol. This protocol essentially like tells the web browser like what kind of language we want to use. We want to use HTTP, HTTPS. How do we want to communicate with this website? There are also protocols like FTP, and that's all I can think of right now. And then the next part is the domain. This is like the kind of the main part of what we need in order to be able to go anywhere. The domain is our like flatironschool.com, right, or example.com. It is it's the, you know, the main name of our resource that we want to get. So in our case, yeah, we have flatironschool.com, example.com. So that's the domain part. Then we have a couple of optional parts. So everything up until now is something that is required. The optional parts, the path and the query string, there's some other parts to a URL that we could add as well, like a port. But most of the time, unless you're running a local server, you're not gonna be worrying about the port too much. But remember, like if you remember, or you're learning to run a local server, if you're running this local server, it's usually on localhost colon something like 3000, right? So this would be our port in this case. With flatironschool.com, we don't need a port, but if we want to navigate to a more specific path on the site, so if we go to, let's go to courses, software engineering, this part that's after our domain is called our path. You might also call it like, I think here it's called a resource. Let's see, yeah, it's called a resource. There are different names for it. This is a more specific explanation essentially of like, where exactly do we want to go? So which subpage do we want to go to? And then the last part, this is also optional. A lot of times, this is not something that you would type into a URL bar. You have this query string, but this is something that you are going to be using in programming. So if you make some kind of request to your backend, with the query string, you can send additional information with that request. So for example, if we have some kind of search query, we might want to add some kind of value to that search query so that based on that query, we can return a different piece of information. Any questions here about the structure of a URL, the different parts to it? Pretty straightforward. Cool.
One quick question.
Yeah.
In a like in flatironschool.com/career courses/coding bootcamp, is there a distinction between, because obviously there's career courses / some other resource. Mm-hmm. Is there a distinction between those two, or is the whole thing considered the path or the resource?
The whole thing would be considered the path. So even if you had something like, you know, coding bootcamp / index.html, this would all still be considered the path. So like what the exact resource is that you want to go to, that like it's everything after the domain, excluding the query string. Good question. Cool.
Thanks.
All right, let's talk a little bit about the request response cycle. This is a big one. We want to make sure that we understand this because this is something that we're going to work with, or that you're already working with every day, whenever you're making some kind of request to a website. And you're going to be working with it a little bit more behind the scenes because you're going to be receiving and sending these requests. So the request response cycle is essentially like how computers talk to each other over the web, right? So we have some kind of browser. We have our Chrome browser right here, and we can make a request to somewhere else, to some other, you know, to get some kind of page. So flatironschool.com here. And we're making this request to a server somewhere. We don't really know where this server is. We don't really know what it looks like. We don't know how far away it is. But we're making this request to get content for this flatironschool.com page. And magically, we're getting some kind of, like, we're actually able to see something on the page, right? This is the response that we get back. So in like super simple terms, the request response cycle is us making some kind of request. This could be a simple GET request, like what we're doing right here. We just want to retrieve some kind of information. We're asking for information. And we're making this request to a server that, you know, we don't really know where that server is, but the server is going to send to us a response back. And the response will likely include the actual page that we want to look at. The response could also be data. It could be like a JSON response. So if we went to api.github.com/ let's do users, right? So we're making a request here to the GitHub API. Luckily, the GitHub API is open and free to use. So we can just type into our URL bar api.github github.com/users, and this will give us a list of all the users on GitHub. Obviously, this is just like the first page, just a handful of them, but this is the response that GitHub sends to us after we make this request. So the request in our case is typing this into a URL bar, hitting enter, and then receiving that response and viewing all this data. So the response can look different and can have different shapes and forms. It could be like a JSON object, it could be just data, or it could be an actual HTML response that will show us a nicely formatted page like this. Questions about the request response cycle? Okay, cool. I want to dive a little bit deeper into the different types of requests we can make. So up until now, all we've done is we've made GET requests, right? Does someone know what other types of requests we have besides a GET request, which will retrieve information for us?
Post.
Post, perfect. What else?
Something about error handling as well.
So it's not like, so I'm more thinking about the different types of like HTTP verbs that we would be using to make some kind of request. So like get, post,
Trace.
Yeah? What was that?
Trace, delete, options, connect.
Okay. Yeah. So let's like keep it basic. We usually work with get, post, delete, patch, put, right? These are different types of HTTP verbs that we can use to make a request like this, and they do different things. They serve different purposes. Just remember one thing that it's a little bit of an odd thing, which is that browsers, so any kind of browsers that we're using, can actually only make two different types of requests. We can only make get and post requests. In order to make something like a patch or a delete request, we actually need to use additional middleware or additional like pieces of code that will make it possible for us to make a request that is not a get or a post request. We'll get into that a little bit more later on, but just kind of keep that in mind. We'll touch upon that in the next few days. So the different types of requests that we can make, the different types of HTTP verbs that we can use are get, post, patch, delete, and there's another one. So patch and put are both for updating some kind of resource. They're really similar. There's a small difference between patch and put. Put will replace your entire resource. Patch will, with patch, you're able to change a particular thing about a resource without having to replace it completely. So, I'm talking about this, and we're kind of like going over these different types of HTTP verbs that we can use because I would like you to get more used to something called RESTful routing. And we will talk about this more in the upcoming days, but I wanted to give you like a quick introduction to this here so that you have already seen it, or maybe you've already seen it through some of the labs as well. So what does RESTful routing mean? RESTful routing is essentially a way to communicate with an application in a like kind of like a structured way. So when you want to develop RESTful routes, or when you use RESTful routes, that means that you are following a certain convention. And if you've kind of heard a little bit about Rails already, you may have heard the phrase convention over configuration, which essentially means we're using Rails because we don't want to make all the decisions. We want some of the decisions, we want to just use the best practices that we all know. We don't want to have to reinvent the wheel every time. Rails gives us a lot of functionality out of the box, but it also means that we have to follow certain rules. So those rules can be a little tedious at first, like to, have to do this particular thing. But you will figure out that it's actually to your benefit, because that means you don't have to figure it out yourself. You don't have to figure out what the file folder structure looks like and all that stuff. So RESTful routing is one of those pieces, which is following like a certain pattern of rules that's going to make it easier for us to build a web application. So let's talk a little bit about the different RESTful routes that we have. But before we do that, does anybody have any questions about what we've talked about here so far?
So when you're talking about middleware to manage patch, put, and delete, is that happening in Ruby, or is that happening in some client-side code somewhere, or neither?
So that the middleware is, we have to build that into our applications, and that part's happening in Ruby or in whatever language you're like making this request.
Okay, awesome.
Other questions here so far? All right, let's go through some of these RESTful routes right here. You can remember that there are always 7 RESTful routes, and the one rule about RESTful routes is that well, I'm sure there are more rules than that, but the one thing that I'd like you to remember is that we're trying to reuse different paths as much as possible. So we have our HTTP verb right here, right? Get, post, patch, delete, and so on. And then we have a path that we use to make this request to. So if we make a GET request to /newsletters, that would be pretty much equivalent to hitting enter here on a URL, making a GET request to like flatironschool.com, or if we wanted to get like all of the courses, if we could go to like /courses. In fact, it nicely redirects us here to a different URL. So this will give us like a list of all of our courses, right? If we go to /newsletters, it will give us a list of all of our newsletters. So this first one right here is usually an index of things, and we get like an index of many things. Then we have our post to /newsletters. This is a route that will make it possible for us to create a new newsletter. So if we want to create a new newsletter, create a new course, we would make a post request to /courses or /newsletters. If we want to create a new newsletter, if we want to like see the form that would create a new newsletter, we would go to /newsletters/new. So for our courses, it'd be /courses/new. This will show you a form, and this is a GET request because all it does is it shows you a form, shows the user a form that makes it possible for the user to like type in information about the newsletter and like create a new one. Similar to the edit, the get /id/edit will also show a form, but it will show a form that's generally like pre-filled with some information about the existing newsletter already, because this is something where we want to edit a particular newsletter. Also notice that we have this ID in here in this particular path. Whenever you're trying to access, edit, or delete or update a single resource, you have to make sure that you keep the ID inside of the URL. We'll talk about these different, what this colon means right here as well. Just remember, if you're trying to access or edit or delete a single resource, always make sure that you have this /:ID in your path, because that identifies that particular resource. If we want to show one particular newsletter, we can go to /newsletter/1 or /2. That will give us one newsletter. And then we have patch and delete. Patch will update the newsletter, delete will delete the newsletter. And we are again here reusing the path as much as we can but combining it with a different HTTP verb. So the HTTP verb path combination is what's important. This right here is not the same thing as our HTTP verb path combination down here. It's important that those two are matched up correctly to do a certain thing, like update, show, and so on.
I have a
Any
question.
questions? Yeah.
Oh, so for the post/newsletter and then the get/newsletter.new, what's the difference between creating a newsletter and then rendering the form for creating a newsletter?
Yeah, that's a great question. So, we generally start, or there's no reason to start with our post/newsletters, but usually you would start with a get/newsletter/new, which will show you, which will get an HTML page that will show you the form where you can edit, where you can input the newsletter information. And then,
so the newsletter then hasn't been formed yet, but then basically you have to like press create and then it'll create that. But then
absolutely,
I guess
yeah,
for the
that's absolutely correct.
post/newsletter, you're creating a newsletter with like all empty values, basically.
Yeah, so if you don't fill anything out, so just like you said though, Nathan, this will like get you the form that will make it possible for you to fill out the new newsletter. And once you hit submit, you are actually making a post request to /newsletters. So it's almost like a you go from this one to this one.
Yeah. Okay, awesome. Thank you.
Cool. Yeah. And the same thing happens with the edit, by the way. So our edit right here, this will show us the edit form. Once we hit submit on the edit, we are going to be making a patch request to our /newsletter/ID. So those two, like with the new and the post, those are always connected, and the edit and the patch, those two are always in a way connected. Other questions here? Great question. And we'll definitely like go into this a little bit more, and we'll repeat this because this is a really important concept. I just wanted to give you a little bit of an introduction to it, so you've seen it at least. Okay, cool. So I'm not going to go too much into detail here. There's some more information here about the requests and responses that we make. We already talked about the different types of HTTP verbs that we have. And this also mentions that you can essentially map these get, post, patch, delete to create, read, update, and destroy, right? So these are your CRUD actions, not in the right order, but still. So we have our read, which is pretty much our get, right? Our create is our post, our update would be our patch, and our destroy would be our delete. But what I do want to do is I would like to make a couple of requests, and we've already made some requests here through our browser. These are all just GET requests. I want to introduce you to a tool that can make these kinds of requests on your behalf without having to like make them in the browser. The problem with just using the browser to make requests like this is that you can only make GET requests, right? Whenever you type something into the URL bar, this is always going to be a GET request. What if you want to make a POST request? What if you want to make a delete request? There are certain tools that you can use to make that possible, to make these kinds of requests. And one of those tools is called Postman, and another one is called Insomnia. I personally prefer Insomnia. I'm not quite sure why. I like the styling of it. But I would recommend you download either one of them. Insomnia. They both do the same thing. So if you go to if you type in Postman, you can download the Postman application here. If you go to Insomnia, see if we can find that here too. HTTP request. There, right there. Cool. So either one, I can send these out to you in the Slack channel if you want to check either one out. It doesn't really matter which one you use. I'm going to show you a couple of examples with Insomnia, and I'm not even sure I have Postman installed right now. So let me show you what we can do here. So Insomnia is essentially a way to make requests. just like we did in the browser just now, we can make GET requests, right? So we're going to make a simple GET request to our Ruby on Rails guides to the getting started page.html. I can hit my send. I can specify here what kind of request I want to make. I'm going to make a GET request. I can hit send here, and it will show me the response of that request. So in our case, this is just like a HTML page, right? Getting started. There's nothing much else going on here. This looks like it would look in the browser, like if we type this into the browser, right? So this is all great, but we are able to do this already. We were able to do this already previously. What we can do with Insomnia also, or Postman, is we can make different types of requests. We can make post, patch, put, delete requests. I actually don't have, we're not able to make any kind of post or patch or delete requests to our Ruby on Rails guides. I just wanted to like show you what the options are here. But I don't actually have a server set up where I can make those requests. Maybe I could have done that. We'll do that tomorrow for sure. But I just wanted to show you that you're able to make different types of requests. So if you wanted to make a post request, which would mean like we are creating some kind of new resource, obviously the Ruby on Rails guides aren't going to allow us to just go ahead and do that, or like deleting a resource, right? So this is usually something that we would do on our own server. So if we wanted to make a post request, we can make that to whatever, in our case, let's check out our RESTful routes here. If we did that to /newsletters, it might look something like this: localhost 3000 /newsletters, right? So we make a post request to that. And with that post request, if we're trying to create some new resource, we have to send additional information. We actually have to send the body of the request. So like, what do we want to create, right? So a newsletter has a title, newsletter has some kind of body or some kind of text content. So this is something that we can send in the body right here. You can send different types, you can add different types of information here in your body. Most oftenly, we're going to use something called JSON. And we would be able to send like additional information to create this new newsletter. Now with Rails, what we're going to be doing is like Rails is actually going to do all of this work for us more or less behind the scenes. So whenever we hit create to create a new newsletter, Rails is going to make this, if we have everything set up correctly, Rails is going to make this post request to our /newsletters with the information needed, and we're able to create a new newsletter. So I would recommend downloading something like Insomnia or Postman to make these kinds of requests. This is a great way to test out your application before having all of the front end created. So
quick question.
Yeah.
With the Insomnia, did you download the designer or the core one?
Oh, that's a good question. I think core. Let's see. Collaborative. Yeah. Desktop. Yeah, the core one. Insomnia core.
Okay. Thank you.
Yeah. Let's see. Yeah. Any other questions about these kinds of requests that we're making, or Insomnia or Postman? All right. Cool. So I actually wanna end it here. This was supposed to be just like a, overall introduction to the internet. What's the request response cycle? Later on, we're going to talk a little bit more about Rack, and then we're going to tomorrow talk about an introduction. We're going to start talking about Rails. I would recommend you look into the labs that we posted today in the channel, which are pretty much like Rails, introduction to Rails, and an introduction to REST, which is what we just talked about. So yeah, if nobody has any questions, we'll end it here.
A question about more, I guess, modern websites, like say Google Docs, where all the processing is not on your computer, but it's still the same thing because we're considering the server to be the web browser, correct? Not the actual desktop or laptop tablet that we're presently using.
Well, the server would be wherever we're getting the information from, and then the client would be like the desktop or tablet or whatever we have that's making that request. Is that what you mean?
So it doesn't make a difference if the server is doing all of the back-end processing or if for some reason the client side is doing the processing. It's just purely
I see
sending
what you
and
mean.
passing the data.
I see what you mean. Yeah, so there are differences between like having kind of the server do a little bit more of the work and having the like the browser do a little bit more of the work of you know, when a user goes to a certain page. There are differences between that. I don't think like we're gonna get into that too much until maybe like JavaScript or React. But yeah, there are differences. I don't know exactly what else, like without going into like too much detail.
Yeah, that's fine. Yeah,
Okay.
Well,
Okay, cool.
I just wanted to make sure that there are some minor differences there, and we can
Yeah.
get to that, you know, when it's more appropriate.
Right, for sure. Yeah, there's like a difference between server-side rendering and client-side rendering, but I think like we're not going to be worrying about that in Rails. More of in like the once we get to more of the front end heavy sites, the front end heavy frameworks like React. Any other questions before we end it here?